Welcome to this Fix with FHIR presentation, which is going to talk about using events with FHIR and how we found this to be a simpler way to unify health data. My name is Myles, and I'm a senior software engineer at Babylon Health. Babylon is a digital-first health service provider and value-based care company. It connects patients with healthcare professionals through its web and mobile application, as well as providing a set of AI-powered tools. The problem that we're going to be discussing today is the existence of silos within healthcare, which make it impossible to retrieve a patient's full medical record from one source in one format. Products exist both internally within the company and externally, and data can be stored in a variety of databases or event streaming platforms. As is a common practice in companies today, we deal with a mostly microservice architecture, so each service has a small specific task and dedicated storage. There is a mix of synchronous and asynchronous communication between these services. Our aim is to unify data across products in a scalable, reliable manner. As an example, we have a user that wants to access information about a patient's height, represented here by circles. Every time we see a circle, it's a height measurement. However, it's been recorded in different formats, i.e. different colors. None of these systems are connected, and the user would need to gather data from each silo to retrieve what they need. To solve this problem, we've taken the approach of defining a set of event streams to store every change in health data as an event. The event streams can then be used to populate any chosen data store for querying. This presentation is about our learning on creating these event streams and why it's been beneficial to take this approach. Each event stream has a schema that's aligned with FHIR, and each stream is owned by a domain, which is chosen to be distinct from any product that changes over time, but it can be informed by the expertise of that product owner. Taking this event-driven approach is beneficial when working with microservices, as it enables each service to simply publish events that represent the current state of the health data they are storing. This allows services to keep their autonomy and remain largely decoupled from a central store of health data. If a service had to directly make requests to a central FHIR server, the service would be tightly coupled to the requirements of that server. Services also retain clear ownership of their data. They're just required to make that data available as events. This means that teams can maintain their specialist knowledge and only need to gain specific understanding of the FHIR resources they're producing, rather than complete understanding of the FHIR standard. As teams have full control over their data, features can be added without extra organizational overhead. Producing events is a lightweight task that all services can do reliably using patterns like the outbox pattern. Streaming platforms that the data is published to, such as Kafka, are also highly scalable. Consider if all services were required to make REST API calls to a central data store. Degraded performance or failure of that data store would result in failures in the services publishing the data. This possibility of cascading failures should be avoided, as it can mean one small failure in the data store can reduce the company's ability to provide care. It's also very difficult to horizontally scale a central server. A final big benefit is being able to process and reprocess the full history of events. It's expected that the events will be accumulated by some service to provide real-time querying, like the FHIR Search API. These event streams, however, don't restrict how that service is built and how it might change over time. Currently, we're using Elasticsearch, like many other companies, to index FHIR events for querying. It's fully expected that as we learn more, we will need to re-index the data or move to a completely new data store as new technologies emerge. But this is not a problem because we can easily create this new data store from the full history of events that we have. The biggest drawback to this architecture is it being eventually consistent rather than read after write consistent. When the goal is accessing a complete health record collected from numerous sources, this is a readable trade-off, but it will not be the appropriate solution for a lot of use cases. For example, when a patient is interacting with a healthcare system, it's likely the data being created needs to have the guarantee of being readable immediately after it has been written. Otherwise, this could provide a disjointed experience where data seems to be momentarily disappearing. We can mitigate this problem by creating domain services that own a certain FHIR event stream. The domain service can provide the read after write consistent API that is required and is then responsible for publishing the FHIR events. These event streams provide the flexibility to have a domain service or not have a domain service, depending on the use case. As services are writing to an event stream rather than a FHIR server, the data validation needs to be done by the streaming platform in the form of schemas rather than doing a full conformance check like a FHIR server would. If there is a difference between a schema and the FHIR conformance logic, then it's possible for an event to have been successfully published but not be valid FHIR. This error is then hard to report to the originating service, as it will have moved on with its processing logic. To mitigate this, the schemas themselves need to ensure events will contain valid FHIR as much as possible. There is some existing discussion of trade-offs in using services on the services page of the FHIR site. With FHIR, we're most used to using a CRUD API. And with events, we still need to make sure that we can create, update, and delete resources. Our simple solution is to ensure that all events have a business identifier. Using this identifier, we can then update the state of any resource. This imposes a few constraints. Firstly, that events need to publish the full state of a resource, and secondly, that events are processed in order. When you think about a standard FHIR server, each event can be accumulated by performing a conditional update on the identifier. This will handle creating a resource the first time an identifier is received, and updating a resource if the identifier is present on the server. Generally, data is not deleted, but rather the status of the resource would be updated to the entered in error value or an equivalent. As an example of updating state, on the right-hand side we can see a series of simple events about patients. The first event is the creation of a patient resource that represents me, Myles. The second event creates a patient called Alice, and the third event is updating my patient resource to correct the misspelling of my name. This can be here done using the identifier patient1, which really would be assigned by the service publishing these events rather than a fake value patient1. When creating the event streams, we spend a lot of time considering the schema of the events. The schemas are used for the business to understand its data and to guide developers when publishing their events. Because people in a number of professions will be using the schemas, they need to be easy to understand, not only to those familiar with FHIR, but to everyone if possible. Furthermore, to address the issue of distributed validation that we described earlier, the schemas need to provide strong type validation of events. When we defined schemas that exactly matched FHIR resources, we found that type validation was too loose, as there are many optional and choice type fields. There's also a lot of nesting and setting of boilerplate values, which did not meet our goal of being easy to follow. This led us to creating event streams that are aligned with FHIR profiles rather than base resources. This gave us the ability to create custom schemas for our use cases and to further simplify the schemas. The biggest simplifications are not needing fields that have fixed values in the profile to be given as part of the event, and also providing enums for fields with value set bindings. I think an example is the best way to bring this idea to life. The aim here is to publish an event capturing a patient's height measurement. On the left here, we have part of a FHIR profile for the height measurement. Two of its differential elements can be seen here. The first is making the subject field required, and the second is setting a pattern for the observation category field. When we generate the schema for this profile, the subject field will be added to the schema as it's a required field. However, the category field will not be required as it's using a fixed pattern. The profile would of course include more differential elements, but I think these two cases illustrate the concept. In our simplified event in the center, we're providing 5 fields, all with simple types that could be understood by anyone. Using the information in the FHIR profile, we can then transform the simplified event into a FHIR event. These 5 fields in bold in the center, you can see on the right-hand side where they go into the FHIR event. To make these simplified schemas work, we have a few extra requirements. Firstly, we need to be able to quickly and accurately create the desired FHIR profiles, though this is common to any FHIR solution. Secondly, we need to generate schemas containing the simplified fields from the FHIR profiles. These schemas would normally be made using Apache Avro or Google Protobuf. And thirdly, we require an extra transformation step to convert from the simplified events to FHIR events. This needs some extra logic and infrastructure. Through having extra custom schemas and a simple transformation step, it's possible to add other simplifications, such as combining multiple FHIR profiles into one event. For the height observation we saw earlier, we could group that with the encounter in which it was measured. We've found that this can help the business move faster to produce high-quality FHIR data. We also add provenance fields to every event, similar to those of the provenance FHIR resource. This provides clear traceability and can be used to establish the level of trust in the resource based on the agents that participated in the collection of the resource. When dealing purely with internal company data, the described event streams can be directly produced to by working with the appropriate teams. When bringing in FHIR data from external sources, we still need to be able to produce that data as simplified events to the appropriate streams, so that we have one consistent place to access all health records. External systems are not aware of our internally created FHIR profiles or schemas and could not be expected to keep up with the regular changes made to them. To bridge this gap, we created a conformance process to find all FHIR profiles that an event matches, rather than only validating claims made by a resource in the meta profile field. Having established what the resource is about, we can then transform the event into the appropriate simplified FHIR resource and write it to the appropriate stream. So in conclusion, through our work at Babylon, we found that the FHIR data model has been a great guide for creating high-quality schemas. The flexibility of the FHIR standard, especially the creation of FHIR profiles, has enabled us to adapt it easily to our use cases and to create simplified schemas that developers have found easier to interact with than the FHIR REST API. I hope some of these thoughts can help you in the projects that you're working on. Please feel free to reach out to me anytime during the conference or after the conference using the Zulip FHIR chat. Thanks for listening to this talk. We should now have time for some questions.
Thank you very much, Myles. Hello, everyone. This is Sadhana Alangar, HSM's Director of Education. Welcome to this Events with FHIR, a simplified way to unify health data presentation. Myles Bell is here. He's joining us from UK to answer your questions. I see that there's one question already. Myles, do you want me to read it, or can you see the question?
Yeah, you read it, please. Thanks.
Can you expand more on these domain services? Are they aligned with FHIR resources, your FHIR profiles, or your own business domains?
So the aim of the domain services is to align them with the FHIR resources. And to get there, obviously, a company has existing services which will not be kind of architected to produce those resources necessarily. So I'd say that in the short term, the reality is that it's more about creating things that the business cares about, so business domains. But certainly in the longer term, we hope to push that towards domains for profiles or even resources.
Thank you. Any other questions? Please post your questions in the question and answer section on the right side of your HUA. Going once.
Okay.
Going
I'm glad
twice.
that the presentation explained completely the ideas. I'm happy to add some extra thoughts that I've had from listening to some other presentations during the conference, if we've got some time left over.
Sure, go ahead. We do have 4 more minutes.
Yeah, great. So I think really what this presentation is almost like trying to address is something similar to what the Argonaut is looking at with their kind of latest FHIR rights kind of milestone, in that we've kind of found that directly interacting with REST is not the easiest thing for most developers, and also then for the business to understand. And we found that kind of like these simplified events have been much easier for people to deal with than directly with FHIR. And in a similar way that like GraphQL has kind of been coming around and been making it easier for people to read the data, it does feel like there needs to be something that makes it easier for people to write data. I also noticed during one of the presentations about sushi that this is kind of this simplification is very much something that it does without kind of creating schemas. If you create a profile in sushi and then create an instance of that profile, it will really nicely do this kind of populating of fields that are fixed. So I think it's definitely something that other projects are definitely looking at, which is really good to see. It'll be nice to have some of those things like make their way into the standard to make the writing of data easier as well.
Okay, there are a few more questions.
Oh, some questions, great.
Actually, there are 3. Are you leveraging a central schema registry to manage, disseminate your schemas?
Yes. Simple
question. Next question? Okay.
Can you
expand more on these domain services? Are they aligned with FHIR resources, your FHIR profiles, or your own business domains?
I think that was the original question.
Yeah, okay. The next one is thinking about access control. What about if data in an event should only be accessed by a subset of users? How do you make sure these services services consuming this data stick to these access policies?
Yeah, absolutely. Obviously, you need to have very fine-grained access controls on the reading of the event streams. In our case at the moment, we don't generally provide access directly to the event streams. We would make people go through the kind of the service that brings the data together and is then used for querying. Obviously, for things like notifications, it might be useful to subscribe directly to a topic to get the data, but obviously that then requires very, very fine-grained permissions on which streams can actually be accessed. Generally, it's not the approach that we would take at the moment, because the the service that's bringing together data has much finer grained controls on what data can be accessed.
Thank you, Myles. With that, we are out of time. And I think you've answered all the questions. Thanks once again, everyone, for attending this session. Thanks, Myles, for this excellent presentation. Don't forget to rate the session. This is Sadhana Alangar, HL7's Director of Education, signing off. Bye, everyone. Bye, Myles.